equation? Multiply. See, if you are absent from the previous class, what is the value you are given? Ys is equal to 1 plus j y r minus. See, this term I told you to multiply by the. After this step I have finished. Yes, I have finished in this step. So multiply by the conjugate value. This one. What is the conjugate value? 1 minus j y r tan theta s by 1 minus j y r tan theta s. Multiply. See, anything into 1 will give you the same answer. So y r plus j tan theta s, then minus j into this term, j y r square tan theta s, then j square is minus 1, minus into minus will become as plus y r tan square theta s in the numerator part. Denominator part, 1 into any term will give you the same thing in the first one. Then minus j into this terms. So minus j y r tan theta s. Then j square minus is already there. So plus y r square tan square theta s. So now this plus and minus term will get cancelled in the denominator term. So in the numerator term, we can group the real term and the imaginary term. So real term is y r, right? First we can write the real term, then we can group it. Y r tan square theta s. This is the real term plus j, and you can take what is the term tan theta s minus y r square tan theta s. First I am separating the real and imaginary part, then I will take the common term outside. So 1 plus y r square tan square theta s. So now in this term y r can be taken outside, right? In the first term y r term can be taken outside. So y s is equal to y r I am taking out 1 plus tan square theta s. In j term tan theta s can be taken outside. So plus j tan theta s I am taking out. So what I will get? 1 minus y r square by. So real and this they are separating. So 1 plus y r square tan square theta s, and here also in the denominator term 1 plus y r square tan square theta s. Are you getting up to this equation? So already how many equations you have marked? 3. So after separating the real and imaginary part, we get the equation number 4. So double step matching, I told how many marks they have asked in the university exam? 10 marks. The derivation is very simple. Sit down. Anita. So after this equation number 4, it is very simple one, right? Just you are writing the equation and then you are multiplying by the conjugate, and then we are separating the real and imaginary. Why we separate as real and imaginary part? One part is your conductance part, the other part is your susceptant part. So whenever in the step problem you have to remember plus j. Susceptant part means it should be compensated with resonance and anti-resonance, so minus j. If it is minus means we have to cancel with plus j in the step problem. So that we have learned already in the theory in the step of single step. Same way, the same procedure is followed here. So in the single step, we are just measuring the length L1, the length L and distance D. Here we are measuring the length L1 and distance D1 and D2 and length L2. So just same way, just we are placing two steps parallelly, right? For what we are, step is nothing but a transmission line. So in order, there is a mismatch in the load impedance with the characteristic impedance. So to match the characteristic impedance with the load impedance, we are connecting the stub. That is the purpose of connecting a stub. So whenever we are placing something, at which distance we have to place and what should be the size of that one is very much necessary, right? So if you are purchasing a trap meat, it has to fit to this basic, right? So according to that only you can purchase. So before purchasing, we always decide what to do, right? Same way, to place the stuff parallelly, where to place, at what distance we have to place, and what should be the size we have to think. So that is only, that's why we are dividing as real and. So first part is your conductance part, next part is your susceptance part. So now the step 1 is located at point A to A dash. Now the step 1 is located at point A, put your hyphen and write A dash. Step. Now the step 1 is located at point A to A dash at a distance S is equal to D1 from the load. D1 from the load. Hence substituting S as D1 in equation number 4. Hence substituting S as D1 in equation number 4. In equation number 4 we get right there you want. In the place of S substitute everywhere as D1 and write the equation number 5. Just substitute for the step 1. We just take S is equal to S1. Step 2 we will take S is equal to S2. That's all. So V1. That's what distance only. S is equal to V1 we have to take. So just substitute in equation 4. S is equal to V1. Just change it 1 plus tan square beta V1 plus J tan beta V1 1 minus y r square by 1 plus y r square tan square beta V1 and 1 plus y r square tan square beta V1. So this is equation number 5. So we say term is taken as GI. Second term is taken as BI. So in the equation number 4, just I am substituting S is equal to D1. So again YS is nothing but the first conductance term is taken as GI. The susceptance term is taken as BI. So we get the equation number 6. So up to step 1, the switch on problem is very easy to do. Step 2 alone you will find it difficult because we have to add with the circle. There only one circle we will draw. But in double step we have to draw with 2 circles. Okay. And marking the points, cancelling 2 place we have to measure. That only one length and one distance is measured. Here 2 distance has to be calculated and 2 length has to be calculated and circle has to be drawn. So the complication will be only in the double step problem. See, the ordinary switch chart problem, not related with the stuff. What is the first thing? Problems using Smith chart. That is why they have given in the syllabus. That is easy if you understand. Second thing is single step also, same way we can do it. Okay. Only we have to measure the distance and length. Only one circle. Only double step, you will find it difficult because so many points we have to do it. Because GS is equal to G naught unity, that one point. So opposite that point we have to find. Everything we have to do the cancellation. So only the complication part will be in the Smith chart, in the double step alone. Okay, so once if you do all this, that calculations also will be easy. Are able to follow? So no doubt. After having written up to equation number 6, and after that you know down when you stop 1, having a susceptance, when you stop 1, having a susceptance plus or minus J B1. When you stop 1, having a susceptance plus or minus J B1 is added at this point. When you stop 1, having a susceptance plus or minus J B1 is added at this point. The new admittance will be Y dash of S equal to Gi plus Jbi dash. In the conductance parts there will not be any change. Jbi dash. The new admittance will be Y dash of S is equal to Gi plus Jbi dash. So that is equation number 7. Since the input admittance of a short circuited stub is purely imaginary, the conductance, that means the real part of the new admittance, the conductance, that means the real part of the new admittance, Y dash of S, new admittance, Y dash of S will remain unchanged. You can see, right? Gi part I didn't put any dash. Y S dash is new admittance. Gi plus J Bi dash. So only in the imaginary part there is a change. The real part Gi, there is no change. Let's note down. Here Bi dash is equal to Bi dash is equal to Bi plus or minus B1. Bi dash is nothing but equal to Bi, the distance of that one plus B1. Bi. This Bi only. Bi dash. Bi dash